Hi dear students, hope you are well. Today I continue for lesson 4 and I will cover pages between 108 to 110. Okay, uh, we still study about electrolysis. Today I would like to explain you about electrolysis of solution which is happen in water. As we can consider a water for a solution, electrolysis in solution deal with water. This is different with the last session I explained you. It was molten salt. Molten salt, if you remember, we have to use heat to keep molten chemical, which is usually salt, and they can easily separate it to two positive ions and negative ions. The positive ions that we call cations, and the negative ions that we call uh, anions. Okay. Um, what important things is pure water produce ion like here. Okay, we have water molecule. It can separate it to a positive ion and a negative ions. Okay, a positive ion is hydrogen and hydroxyl. It's not enough to conduct electricity. The solution, the water, can produce two part positive and negative ions, but this solution is not same as molten salt. Molten salt is completely separated, but the water is not completely separated. Just a few molecules of a water in solution can be separated. Okay, not all the molecules. So that's why water is not uh, very good conduct electricity in this case. I mean, next slide can explain you about the electrolysis of concentrated sodium chloride in solution. Okay, um, sodium chloride is NaCl, which is solved in water. Okay, we have water and we have NaCl, which is dissolved in the water, and um, sodium positive ions can be separated and the chloride can be separated, and OH hydroxide ion can be separated from the water, and the hydrogen here can be separated from water. In contrast, the last session that I explained, here we have four part, two positive ion, two kind positive ions, and two kind negative ions. Based on the reactivity between hydrogen and sodium, which can be observed on cathode. Okay, as I wrote here, positive ion are attract to a negative electrode to get electron. Okay, but which of them? Here between the sodium and the hydrogen, sodium is can attract and hydrogen can attract, but hydrogen is more reactive. Okay, hydrogen is more reactive than sodium. So when the hydrogen reacts to the cathode, to the negative electrode which we called cathode, the hydrogen can get electron. Okay, then here, as you can see on the equation, hydrogen can get electron and convert to the hydrogen atom. Then after that, the hydrogen atoms, each two hydrogen atom can react and make a hydrogen gas. Okay, hydrogen gas can release from here. Why? Because first hydrogen react with the cathode, they don't have enough electron, they are looking for electron, they get electron from the negative cathode from here. This electron comes from where? Comes from the battery. Okay, the battery gives electron from here. Okay, get the electron and two neutral form atoms can react and make a hydrogen gas. Then the gas can release from here. Okay, gas will move out. This kind of reaction is reduction. As we learned before, if get electron, okay, increase electron, get electron, we call reduction. But what happened for the sodium? Sodium is deposited here, okay, stay here. On the other side, what happened in other side? In other side, here is battery, okay. The battery, this positive side of the electron is a lack of electron. There is not enough electron. This is positive anode, okay, positive electrode that we called anode. The anode can get electron from the anion, from the negative ions, okay. Okay, here between hydroxide and chlorine, okay, between the color, here color can react with the positive anode, can give electron, okay. Then finally here, okay, the chlorine ion can give electron and change to the color atom, okay, chlorine atom. Two chlorine atom, two of them, which is atom form, which is neutral, can react to each other and produce a chlorine gas. So between the hydroxide and chlorine chlorine atom ions, here the chlorine is winner, can react with anode and give the electron, okay, and following this reaction. So what happened for the hydroxide? Hydroxide can left in solution, can stay in solution, okay, cannot move out from the system. When the chlorine ion can give the electron can move toward the positive side of the battery, okay. Okay, what kind of reaction here we have? Negative ions are attract to the positive electron and lose of electrons, okay. This negative ion, they give electron, they lost their electrons, so we call oxidation. We had before we had this definition, if a particle lose electron, we call oxidation. If the particle or atoms get electron, we say reduction. Keep in your mind this definition, which these are important. Okay, finally, from these four particles, these four ions that we have, two of them can release in form of gas, like chlorine gas, like hydrogen gas. So finally, the sodium atoms and hydroxide atom here can react to each other and make a sodium hydroxide. Okay, so sodium hydroxide is created in solution. If you remember what we had before at the first step, we had sodium chloride, sodium chloride, which was dissolved in water. We had another solution, but now finally we have hydrogen gas. At the end, the production is hydrogen gas, we have chlorine gas, we have sodium hydroxide solution dissolved in the solution. Okay, so finally the production become changed. So there is two notes: always the most reactive metal cation and the most reactive non-metal anion attract to the cathode and anode. I back here to the previous slide. Here, the most reactive between the hydrogen and sodium can attract to the here cathode, and the most reactive between non-metals. These are metal. This is non-metal. Non-metal are negative negative ions like hydroxide and chlorine ion. The most reactive will attract to the anode. Okay. Note 2 is product is different between analysis in molten salt and analysis in solution. The molten salt, if you remember last session, that we had one salt, molten salt, and we had two kind of particle, positive and negative ions, and both of them were absorb on cathode and anode. But here we have four particles, two positive and two negative. Just one of these two can attract to the anode and cathode. The other two left can be left in the solution. So the product is different. That's all for today, and please leave a comment down on your Google Classroom as your attendance. Thank you so much.